In this video, I'm planning to explain again limits involving infinity. This time, when the limit goes to infinity, the result is infinity. It will be. Here, this example also shows, this graph also shows that when the x values are going to infinity, the function is going to infinity, so the y is infinity also. So limit value for this function, it's going to be infinity. Generally, when the function goes like this, the graph will stop because the coordinate plane is ending here. That's why graph will end here, but it means that this graph goes up, which means infinity. Or here, limit extends to minus infinity. When x goes to minus infinity, this case it is minus infinity. When it goes to minus infinity, the function is going to minus infinity side. The y value is minus infinity. Here the y values are important. You heard many times about that one. While we are finding the limit, we are finding the y value of the function. So this is the graph of the function, and the y value is important here. Okay, when x goes to plus infinity, it goes to infinity. When x goes to minus infinity, again it goes to plus infinity. These are the possible cases. Okay, now for the question, we are going to find the limits of the functions, but here we have the numbers and we have the infinity values. For the infinities, we don't have infinity plus or minus usage. Infinity plus we cannot apply, but for the values here, which is 1, minus 1 and minus 2, we have to calculate. For finding the limit, we have to check left-sided limit and right-sided limit. Limit extends to, I'm solving the normally here the C1, limit extends to 1 fx. We should check limit extends to 1 from the positive side fx, and we should check limit 1 extends to 1 from the negative side of fx. We have to find these values firstly. Here the value is 1, as you see here. It goes to from the 1 plus here. The 1, when you get closer to 1 from the positive side, the function value is going up, which is infinity. So the result here is going to be equal to infinity. Result is infinity. Okay, from the negative side of 1 from the negative side, the function is going to, so the y value is also same, is going to infinity again, and left-sided limit and right-sided limit is same value. They are both going to infinity. That's why limit extends to 1 from limit extends to 1 fx, it should be equal to infinity. And if you remember, left-sided limit is equal to right-sided limit exists, and it's equal to that value is going to be. Okay, now I will continue with the first one here. Limit extends to infinity. Also, this case, limit extends to, when x tends to infinity, when x goes to infinity, where the function is going, we need to understand that one. The function is going like this, and this line is called asymptote. I explained before. This line is the boundary, so this graph cannot pass the -2 line. That's why limit of fx when x goes to infinity, boundary is going to be -2 for the function. This is the A1. And the B1 is here, limit x goes to minus infinity. X goes to minus infinity. What is the fx? We are asking that one. X goes to minus infinity. This is the x-axis, and I'm checking x goes to minus infinity. What about the function? Function is here. Function is also going to that side. My function is going to, here the value is 0. So the y value is going to be 0. And be careful about that one. plus infinity doesn't mean that infinity plus, or minus infinity doesn't mean that infinity minus. We have to be careful about that one. Okay, I'm going to solve the second one, and I'm going to solve the fourth one, and I'm going to stop here. Limit, the other one is going to be homework for us. Limit x tends to 1 from fx, first let me write, then 1 from positive side, 1 from negative side. Limit x tends to 1 minus 1 from the positive side. Actually, this is minus 1 from the positive side. Here, minus 1 from the positive side. Limit x tends to minus 1 from the negative side. Fx is going to be. Okay, then 1 minus 1 plus, here it's going to be equal to minus 1 from the positive side is going to be equal to, let's check on the graph. For the graph, I'm going to clean this part here. Now I'm going to get closer to 1. I'm going to get closer to minus 1. Sorry, minus 1 from the positive side. Minus 1 to positive side. This is minus 1 from the positive side. And when I get closer to, I'm checking the function. Where is the function? Here. These values are getting closer to this one. What is the value on the y-axis? 1. So the value is equal to 1. Minus 1 from the positive side is equal to 1. Okay, now I'm getting closer to minus 1 from the negative side. Minus 1 from the negative side, and the function is getting closer to, at the same time, this value. The blue one is the function. So on the y-axis, this value is equal to 0. So left-sided limit is not equal to right-sided limit. Limit doesn't exist for minus 1. Limit doesn't exist. Here we have limit combination theorem. Limit combination theorem allows us to do operation between the limits and the limit values of these expressions outside here we have addition. Outside that addition, we can move the addition outside, because the limit values, as you see, limit of fx is equal to a and limit of gx is equal to b when x tends to x0. These are for all same, x tends to x0. So if there is addition, you can carry the move the addition out, subtraction out, multiplication, division, or if you multiply by k, that value you can multiply the result by k again. We are going to apply the limit combination theorem with the question limit x tends to 0 from the positive side and negative side. Then the third one is, do we have the limit or not? They're asking that one. It's going to be equal to 1 over 1 plus 2 to the power of 2 over x. It's going to be, normally you can apply the value directly, but I want to show the limit combination theorem here also. 2 to the power of 2 over x. So this can be written like limit x tends to 0 from the positive side 1 over limit x tends to 0 from the positive side 1 plus limit x tends to 0 from the positive side 2 over x. It can be, and the results, they are not going to change if there is no variable. The constant function we are going to accept, and we are going to replace the constant value there. This is going to be 2 to the power of 2 over 0 from the positive side. This is 1 over 2 to the power of 1 over 2 to the power of infinity. It's going to be infinity many times. If you multiply the 2, the result is going to be infinity, so it's equal to 1 over 1 plus infinity. When you add infinity to 1, it's going to be 1 over infinity. Then the answer is going to be 0 for this question. Okay, this is the first one, and here we found the 0 from the positive side. Let me find the second one. Limit x tends to 0 from the negative side. It's going to be 1 over 1 plus 2 to the power of 2 over x. Again, the question is same, but this time I'm not going to limit combination theorem. I'm not going to apply the limit combination theorem. Directly I'm going to replace the value 1 over 1 plus 2 to the power of 2 over 0 from the negative sign, which means 1 over 1 plus 2 to the power of minus infinity. This is, and 2 to the power of minus infinity, it's equal to 1 over 1 plus 1 over 2 to the power of infinity, because the power is negative. 2 to the power of infinity, it's going to be 1 over 1 plus 1 over infinity. 1 over infinity is equal to, if you remember, it was 0. This tends to 0. So 1 over 1 plus 0. Then the answer is going to be equal to 1 for this question. Left-sided limit and right-sided limit, as you see, limit x tends to 0 fx. Limit doesn't exist for this case because left-sided limit is not equal to right-sided limit.